This lesson is going to be about the atom, and the learning target is to know the subatomic particles of the atom, like the protons, neutrons, and electrons, know the locations of them, and know the charges on these subatomic particles. So when we're talking about the difference between atoms and elements, we've learned about elements before, but atoms are the smallest unit of matter. And when we were learning about elements, it was a specific type of atom that makes up an element. And an element is any material that's made up of one type of atom. So if I'm talking about the element oxygen, I'm saying I have only oxygen atoms in this substance, whatever that is. If I'm talking about nitrogen, I'm talking about a group of nitrogen atoms, or I'm talking about um, sodium, that's an element, it's a certain type of atom. And understanding the differences in the atoms helps us to understand why they make up certain elements or different elements. And so when we look at what parts of atoms affect the type of element that we have, we're looking at the number of protons. And that's going to be something called the atomic number, which we'll learn about in a later video. But each element has atoms that have a specific number of protons. If we change the number of protons, we're changing the type of element that atom is. We can change the other subatomic particles in the atom, like the neutrons and the electrons, without affecting what type of element. But the element is specifically tied to the number of protons in that atom. So the three subatomic particles that you've probably heard before are the protons, neutrons, and electrons. And there's some key differences between these. The protons, as you can see over here, have a positive charge. The protons are positive. The neutrons, oops, we don't want to write we don't want to write this, are neutral. I always think about them as neutral, or they have no electric charge. You can see there's no plus or minus for that neutron in there. And for the electrons, they have a negative charge, minus charge. You can see those little minuses float around here. And if we look at the locations of these, because remember, what we're trying to remember here is what are the different particles in there, protons, neutrons, electrons. What are their charges? We just said that right now. Protons are positive, neutrons are neutral, and electrons are negative. And then where are they located? The protons and the neutrons, these two right here, are located in something called the nucleus. And you can see that right here. They're located in the nucleus, this really dense mass in the middle of the atom. Atom's mostly empty space, but in the center of that atom, there's something called the nucleus, and that holds the protons and the neutrons. And then we also have our electrons, which are around the outside of the atom. These are floating around, flying around the atom, and they're much smaller than the protons and neutrons. They have a lot less mass. They have the same amount of charge, just opposite of the protons, but they're located on the outside of this atom. Now in the previous picture that you saw, the electrons seemed like they were kind of floating around randomly. They looked like they were going around in circles, but they maybe didn't look exactly the same as these pictures that you're seeing now. One thing about the electrons is that there are different energy levels, and we don't need to know a ton about it, but we have to know that there are certain energy levels that these electrons can be in. You can see that this atom here has one ring around it, one energy level that the little electron is in. You can see that this atom here has two different energy levels. You can see that this atom over here has three energy levels. You can see how many electrons are able to fit in each energy level. Now on the first one, we have just 2 electrons. In this next energy level, we have 6 electrons in this energy level right now, the second ring around this atom. But that energy level can fit 8. You can see over here that in our second energy level, we have 8 electrons in that energy level. And we can see that energy levels after that also have 8. This one out here, the third energy level, has that. And this word's going to come up over and over, but the farthest outside energy level, the farthest away from the middle of the atom, is called the valence electrons. The electrons that are in that energy level, the furthest outside, they're the ones that are least attracted to the nucleus of the atom, and so the most likely to be involved in bonding, or they actually are the ones that are involved in bonding. And so this word is going to come up over and over, but the valence electrons are the farthest outside electrons in here. So when we're talking about what the charges do in the atom, that's an important part of really everything that comes into chemistry, is because of the different charges between the protons and the electrons in this atom, that causes some attractions. You probably know that opposites attract. Well, where did that come from? One place that came from is that the positive and negative charges of the electrons and the protons are attracted to each other. And so this is what holds the atom together. Well, it's what holds the electrons close to the nucleus because we have these positive protons in here. So this nucleus is pretty positive for our lithium here. Positive, positive, positive. Actually, I believe these red ones are our protons. There should be 3 of them. So let's just put them right on there. We've got our protons. We've got our neutrons right here, these gray ones, which again have no charge at all. So we're going to get rid of this. And we've got our electrons floating around the outside, which are attracted in to these protons in the nucleus because opposites attract. Now, when we have an atom, you can see right here we have this is labeling as a neutral atom. It's going to be important that we're able to keep track of how much positive charge and negative charge there is in the atom, how many protons and electrons there are, because a neutral atom means that we have the same number of protons and electrons in that atom, right? Once this number gets to be different from each other, when we have more or less electrons than protons, we end up having something called an ion. But when we have a neutral atom, we have 3 protons and 3 electrons, and so they cancel each other out. As far as the charges go, we would have a +3 and a -3 for charges, and we wouldn't have any sort of net charge. They balance each other out. So this is considered a neutral atom when we have the same amount of protons and electrons in our atom. And just to show this part of what we talked about at the start, that each element has a specific number of protons in its nucleus, when we have boron here, we have now 5 protons. In lithium, the last element that we looked at, we had 3 protons. Now we're still neutral in this boron because I have 5 electrons, and so I have 5 protons and I have 5 electrons, and so I have a neutral atom. But I really wanted to show that as we added more protons, we're changing the element's name. If I added one more to this, that would be carbon would be our element there, where we have 6 protons in the nucleus of our atom. And so you'll get to know this as you get to know your periodic table a little bit better, but that's a really important thing to note, is that our protons changes our number of, our number of protons changes the element that we're dealing with. So again, what you really want to take away from this is, what are the subatomic particles? Our protons, our neutrons, and our electrons. What are their charges? Well, protons are positive, neutrons are neutral, they have no electric charge, and our electrons are negatively charged. And then what are their locations? Our protons and our neutrons are found in this thing here called the nucleus in the center of the atom. And our electrons are around the outside of the atom, taking up it's mostly a lot of empty space. And our electrons are these tiny, tiny little particles, smaller than even the protons and neutrons in our atom, that spin around and do a lot of our chemical reactions, our chemical bonding in here. So I hope that this helps with knowing the subatomic particles of the atom.